Welcome, everyone, to the Ad. Podcast. This is Vaughn Vernon, your host, and I have with me today Fran Mendez. Fran is, among other notable things, he's the founder of the AsyncAPI project, and we'll learn more about that. And we're going to talk about AsyncAPI and Event-Driven Architecture today because that's a real specialty of those two topics. So welcome to the podcast, Fran. Would you like to tell us a little bit about yourself?
Thank you. Yeah, sure. Thanks for the invitation in the first place. So yeah, as you said, my name is Fran Mendez, and I work as the director of AsyncAPI Initiative, and also working on as a director of engineering at Postman currently.
Yeah, so Postman the company has become your async API sponsor, right? And you've brought your team in.
Yeah. So yeah, I will say that it's more than a sponsor, right? So there are multiple companies sponsoring AsyncAPI, but some of them, including Postman, are doing a bit more, actually much more, which is hiring people full time to work on AsyncAPI exclusively on AsyncAPI. And so yeah, we're 12 people on my team working exclusively on AsyncAPI at Postman. So that is really cool. That is really valuable, and yeah, and we also have Solas who have people working part time on AsyncAPI, which is also super valuable, and it's always like it's a blast, right? So because you need time, you need engineering time basically.
Oh, yeah. Yeah. Well, I'm well acquainted with open source products and projects. And yeah, it's you've accomplished something that we were unable to with Zoom, and that's get like a major, I guess, not even sponsor, but beyond sponsor, I guess. Um, I don't know, like a little ecosystem to work within or something. Yeah. So that's great. Can you tell us what is async API? First of all, it sounds like open API maybe, but a little bit different.
Yes. Yeah, so the inspiration is actually coming from OpenAPI, right? So I was working on a product that was mainly based on OpenAPI, relying completely on OpenAPI. And so I was very proficient with OpenAPI at the time. And I saw that we didn't have anything like this for messaging protocols like RabbitMQ, right? So and I'm saying RabbitMQ because that's what I was using at the time, right? So yeah, I decided to create Async API. It was more like an experiment or side project, if you want. Um, and I called it Async API because yeah, it looked a lot like OpenAPI because Async API itself looks a lot like OpenAPI, but for asynchronous communication, right? Synchronous APIs, if you want. And yeah, so Async API started as a specification and one or two tools just to generate code and docs. But what is Async API today? So Async API today is, I would say, it's a huge initiative. It's a growing community of people. It's it's mostly the people, right? But of course, we still have the spec, the tools. We have a bunch of tools, lots of tools, way too many. I would say that I cannot even track them all, and and that is really cool because that means that the community is super active and they're experimenting super quickly. And yeah, so Async API today is a huge community. It's a vibrant community, as you used to say, and and yeah, that's what I would say. But Async API, the spec, it's it's precisely this, a specification to define asynchronous communication using asynchronous protocols or messaging protocols. Um, of course, you can still use HTTP, but the main target, I would say, is messaging protocols, right? So the idea is to define this kind of interactions, like who's publishing a message to a broker, who's subscribing, who's doing this, doing that, what's the name of the channel, where is the broker located, where can I find it, what do I need to do to connect to the server, do I need to provide some credentials, which type of credentials, all these details that you might need to consume, to start consuming or producing messages to a broker or a WebSocket server or something like that.
It's a bit different, although if you look at an OpenAPI spec file and an AsyncAPI spec file, just in terms of the YAML that's used, and at a quick glance you might say, oh, that's an OpenAPI specification, and it's not. But so people would probably be familiar with the kind of file, I guess, format and schema that you're using. But how does it differ? Like, so you're not necessarily using like URLs to say this is what this is how the request is being made, and you're not describing necessarily body payload of the messages and things like that, right? Or is that untrue?
That's partially true. So also we don't define URLs like per se. We start with channel names. Channel names, for those who are familiar with Kafka or RabbitMQ, this is what, and MQTT as well, this is what's usually called topics. So yeah, we start by defining the channels, and then inside each channel you can define the message that's going to be either sent or received or published or might subscribe there. And you can define the message payload, you can define the message headers, or you can just opt to leave them empty and undefined, right? So some people opt to or chooses to not to do it because it's not relevant for them. They just want to have a list of topics or channels. They want to have this list, but they're not really interested in the content of these topics or these messages. So yeah, it's weird. It's usually the opposite. Usually people are interested, but it's a case. And of course there's another part of the spec that allows you to say, like, so this application is sending a message to this channel or this topic, and it's subscribing to this other topic, right, or this other channel. So yeah, that's mainly what an AsyncAPI does, describing the whole set of things, including the message payload, which can be done through JSON schema and Avro as well, YAML data types. So it's not coupled to any specific schema language.
Yeah. So at one point, I guess you can kind of, sort of have a layout of your messaging topography or something like that, topology, where you have this is who this service is talking to this service through, this channel and this particular broker, and here are the credentials, or yeah. So so then you said you were working on a project that used RabbitMQ, and you didn't have something like OpenAPI for messaging, but that doesn't explain exactly why you thought you needed it, right? What was it about what was missing to you that you really needed, that you thought OpenAPI, or what became AsyncAPI, would help you with in the same way that OpenAPI does with REST?
So initially, what happened is that we were in the very, very beginning of building our microservice architecture. So we started out with probably 3 or 4 services, more or less. I don't recall exactly, but it was just 3 or 4 services. And from there up to 20 services or around 20 services, it only took us like a month, right? So in a month, we went from 4 to 20, right? And we were going to add more because of the granularity of each of the services. And that's the problem. Like it was an explosion, and we were expecting more explosion, right? More number of microservices to be added and to be maintained and changed over time, right? So we needed documentation. We were documenting them manually, but at some point, these microservices evolve, right? These microservices usually change. They change the message payload, the message headers, whatever that they're sending to the broker, and that's impossible to maintain, right? Manually, if you want. So yeah, and aside from that, what happened as well is that most of the services, because we were using the same framework and the same language for all of them, we were a young startup, and small startup, so we were using basically the same technology stack for each of the services. So we wanted to generate most of the code, right? So each of the services were looking almost identical, except the business logic in each of these services. The rest of the code was the same. Like 90% of the code of the service was always the same, independently of the microservice. So yeah, it was insane that we had to maintain all of them, right? All of this code in each of these microservices, and if there was a new version of one of the libraries of the framework, you have to update it in all of them and make sure that it's updated in all of them. So we wanted to somehow have a tool that whenever you created a new microservice, it could be generated to be exactly or almost exactly as the rest without having to worry so much about this boilerplate code, and you could focus on business logic. And that's precisely why we did it, right? Like why I did this specification and why we implemented it in the company at the time, right? So that we could be more, let's say, agile, right? In the good sense that we could develop faster because we were a small startup, as I was saying. So our resources were limited. Our time was really limited. So yeah, that was mainly the reason.
Good. Thanks for explaining. And now, say that you have, like you said, you start out with 3 microservices and you use a YAML file to describe the way that the messaging works between these 3 microservices. Does each microservice have its own YAML, and you kind of have an include that references those? How do you individually describe services, and also how do you put them together as a whole?
So yeah, that's precisely the model. Each of the services has its own AsyncAPI file, either YAML or JSON, and that was usually in the same GitHub repo, along with the code, and along with other documentation or other stuff. So we quickly realized that that wasn't a smart decision, I would say, because it's cool that the AsyncAPI file is along with the code, and it can be maintained by each of the teams that it's maintaining the service itself. That's really cool. But unlike REST APIs or HTTP APIs, and in this case OpenAPI, the communication is so that the messages that you are sharing with other services via broker is shared precisely, right? So the same definition that it's going to be used in one of the microservices for a specific message will have to be defined again in another AsyncAPI file on the other service or in multiple services. So what we did in this case is that we started managing a GitHub repo of common definitions of message definitions, right? Because we realized that the messages were not actually owned by any of the services. If you want, you can say that the producer is the owner of the message, but in some cases you have multiple producers. so who's the owner, right? Which team is the owner of this message? So no one is, or all of them are. Um, so we put it on in a central registry. There were not any schema registries at the time. So we put it on a GitHub repo, and we started referencing these definitions from the AsyncAPI file, right? From each of the AsyncAPI files, which is cool that you actually asked that, because on version 3 of AsyncAPI, which we're releasing in June this year, we actually took care of this as well. And there is a new kind, if you want, new kind of AsyncAPI document that allows you to serve as a registry of messages of reusable objects, right? So something that doesn't have any operations. It doesn't have send or receive or publish or subscribe, nothing like that. It just represents a set of reusable objects that you can share across AsyncAPI files. And I think we think this represents a cool opportunity for schema registries to integrate with, right? So starting with Confluent Schema Registry, for instance, they're integrating with AsyncAPI as well. So yeah, it's an Epicure as well from Red Hat. They already did actually. So yeah, I think it's going to become a powerful model, right, of reusability if you want. So yeah. And now I forgot if you asked me that or what was the question.
Yeah, so no, that was exactly I think on the lines of so you kind of have this import or include kind of thing. Now that does open yet another little potential gotcha or complexity, and that is versioning of each schema, right? So now can you use this sort of project wide or system wide description file or registry file to also describe versions, so that one service could be dependent on this version and a different service could be dependent on another, and that way not necessarily even a breaking change, but an unnecessary change for one service, they can still consume the newer schema. You get what I'm saying. How does that work?
Yep. So this is not managed by AsyncAPI in any way. So what we do instead is we provide a way for developers to reference the schema definition. And there is a version field on an AsyncAPI file itself. So you can version your AsyncAPI file as a whole, but not each of the independent messages that are being consumed or published on each of the channels. But that's the cool thing. And that's why I was saying, it introduces lots of new potential cool things, right? With integration with schema registries. And it's that schema registries do support versioning, right? And this versioning is usually included in the HTTP URL that you can use to grab the schema remotely, right? So in the URL or in the headers, or depending on the schema registry. So that's how we handle it. Actually, we leave it to the schema registries, to those who want to version the messages, to actually reference it from the AsyncAPI file. So in the AsyncAPI file, you will just put an HTTP URL pointing to the schema registry to specific message schema, right? Specific Avro definition or JSON schema definition. And it will contain the version, right? It will be to a specific version. So you can link to any of them, actually. That said, your code will need to be ready to accommodate it, right? So you need to be sure that each of the services, even though you're subscribing to a specific version of a message, you need to be able to, if you specify that on a single topic, on a single channel, you might receive multiple versions of the same message. Every service needs to be aware that this might happen, and it will only process those messages of the version that you need. So you need to be flexible parsing the messages because it might not contain the structure or the information that you need because it's another version. So it's a future version that you didn't update yet, right? So that's one way. The other way that I started doing early on with AsyncAPI, and actually it was part of AsyncAPI, but I removed it from the spec because it was causing a lot of confusion. It was like if you want a specification or a naming convention for topic names, right? For queue names, for topic names, for channel names, if you want. So, like a set of rules that you could follow in order to actually have meaningful topic names. It was including, along with the version, it was including the organization that was producing these messages, or the owner of this topic, right? The organization that is the owner of the topic, the department inside that specific organization that's the owner of this topic. Like I said, I don't recall exactly all the parts, but it was like the version, the name of the topic itself, like it said that a new product has been ordered, something like that, product ordered, something like that, and precisely because not all of the topics were events, or they were containing events. Some of them were containing commands as well. So you could actually add, instead of product ordered, right, with the ed at the end in past. Instead of that, what I was suggesting is that you do product dot ordered, right? So, and the dot was to separate the topic name from the action or event name. So, for instance, if you want to have an event topic, you will do product dot ordered. But if it's a command and you're actually sending a command, not an event, it will be product dot ordered without the ed at the end, right? So it's an action, it's a command. And along with that, you could add more stuff like succeeded, failed, completed, so that you could have different topics for different kind of life cycle stages of an event, right, of an operation, if you want. So yeah. But it was causing more confusion. I removed it, as I said, because it was causing more confusion. People thought in the beginning that you had to actually name your topics like this to use AsyncAPI, and I was like, no. This is just this is just a suggestion that I'm using myself, and I think it's cool because you're following the topic, the naming convention, you could parse the topic name and actually quickly get meta information like who's the owner, what's the version, and so on, right? So you could automate stuff on top of that, and yeah. But like I said, I still keep it on my personal GitHub account, that work that I did, but yeah, I didn't talk about it anymore, and because it was confusing lots of people. But yeah, that's another option. You version the topics. Putting the version on the topic name itself. That's one way. So there's no failure, right? If you subscribe to this topic, you're always going to receive this version. Of course, it has downsides because if you iterate quickly, you'll end up with 10 or 20 topics, doing the same thing, and that's a waste of resources, and it's expensive, right? It can be expensive at scale. So yeah.
and just confusing.
And confusing.
Just
Yeah,
plain
yeah.
confusing.
Like
Yeah.
who's using what?
Yeah. So now let's talk a little bit about the fact that you used YAML. And I don't know, some people just seem to be like, oh yeah, YAML is just yet another markup language writers. Um, but, it can be a little squirrely, as we can say in the United States. It's like kind of finicky about spaces and things like that. And a lot of people aren't really attuned to, spaces being important and so forth. And so how do you tame the YAML? What kind of tools should we use so that the YAML sort of doesn't really matter? All that we're worried about is, describing our topics and queues and routings and even message schemas and things like that. What do we do?
I don't. I don't
you
tame.
just get used to it. You just live with
I
it.
got used to it because the other option was JSON, and I was like, no, that's even worse. So because I gotta type a bunch of more things, and that's slower. So yeah, I feel you. Like I don't think that it's just you get used to it. I experimented after that. After releasing AsyncAPI, I experimented with Tunnel as well, but Tunnel can be a big mess in the very moment you nest things inside each other in multiple levels. So, and XML was just like too verbose, like even more verbose than JSON, right? So,
and then,
so I was like, I think it's a necessary evil, right? YAML is a necessary evil, maybe.
Yeah. Someone conclude that their site might be impaired by angle brackets. If you're using XML, so it's not the funnest document description to read, but it is a true document description. And
it is.
So, yeah,
and it's powerful. It contains features that JSON don't have, and that's actually. And before you jump to another question, like I would like to add that because I don't fully like YAML, I've been experimenting with other formats, and there is one which is called Cadel, and that is confusing because there are two named like that but spelled differently. One is from Microsoft, which is CADL, Cadel, and the one that I'm referring to is KDL, which is also pronounced Cadel, and KDL is kind of like a mix of YAML and JSON, but looks a little bit like somehow looks like the GraphQL schema language as well a little bit. It has the XML. It has XML functionalities as well, or XML features, which is cool. And I must say that I'm liking Cadel a lot. So I may propose in the future that we start supporting this new format as well as another option, right? As another presentation layer, if you want, because in the end, JSON will be the default for tools, and YAML, Cadel, and whatever else you want to invent. It's just a presentation layer. As long as it can be converted down to JSON, which is what we do in every tool, you can use whatever you want. Actually, we don't care. So yeah.
So it's so interesting. You're even taking the YAML and turning it into JSON.
Yeah, that's what we do. We don't support YAML per se. It's just we say it in the spec in the beginning. We say that we only support the YAML features that can be converted to JSON, right? So there are no references or pointers that you can use in YAML and other magical things, which might be useful. But yeah, like we don't support YAML per se. We support JSON. That's what we ask people to support. YAML is just another another presentation layer if you want for the information,
Yeah.
and so it's relevant.
So if we went on the scale of evil to good, XML in terms of, I don't know, readability, usability, very strong in some ways, but bad in others. And then we take maybe a step up, and JSON is less evil, but still, like getting there. And then YAML is maybe in ways, it's at least less verbose. Now, KDL, is it like good or just less evil? This is what I'm driving at.
I would say it's more, let's say, it's better than YAML in this sense. So it will be in the direction of good, not in the direction of evil,
okay.
right? So and now that actually that you asked that and you mentioned XML, like the evil example, I would say to me that's not the worst one, right? So TOML to me for this kind of situations, not for plain configuration files, is cool. But in this case, TOML will be even more evil and difficult to read, right? And to consume. So, yeah.
And XML was just never meant to host, objects, and that's how we were mostly using them. For using XML for however many years we thought that was a good idea, and and then and then someone was like, yeah, but this isn't really describing objects very well, and you need like 5 times as many bytes or characters to describe what you want to do than the actual data, and or probably even worse than that. I don't know, probably maybe a magnitude worse, more characters. I don't know, but it's just we're probably talking about YAML too much. But I have to say I have to look at KDL because I have never really seen a configuration format that I like. Never, that I really go like, wow, this is like, I would really not hate doing this, So
yeah, I felt that. That's what I felt with Cattle actually. Like, oh, like this is. I mean, it's not perfect. It's not. It's never going to be perfect. It has decisions that I may or may not agree, but that I respect and I understand why these decisions were made. So, and I still agree that it's better than YAML or JSON. So I think it's a win, and I hope it gets more popular. So Cat Marchand is actually the developer behind it. So yeah.
Yeah, I'll take a look. I would like to see that. So you said that you have so many tools that you don't really know all of them, which happens, right? Some people say, "Oh, this would be really cool," or I need this, and so they develop it. They leave it open or offer it openly to the community. But what are some of the tools where you say you really shouldn't live without these tools? Like, and what are they, and what do they do for you when you're using AsyncAPI?
So I would say that the main one is my beloved generator, and I say beloved because that was my first tool, and it's still there, growing. It's mainly stable. We're not adding so many features anymore. But the generator, it just allows you to generate anything from an AsyncAPI file. And I say anything because it's based on templates. So that depends on what's on your template. You can provide your own templates, right? So it's just like a template engine on top of Node.js and React as well. So yeah, you can actually generate anything from an AsyncAPI file. You use AsyncAPI as an input. You execute the template, and it produces an output, right? Which could be multiple files, actually, not just one file.
And you must have a collection of templates that cover a lot of different situations.
Yeah, exactly. So the generator is just like the engine providing that functionality. The real value, I would say, it's on the templates themselves. And we maintain an HTML template, Markdown template, Node.js template, Java template, Java Spring Spring Cloud Spring template, Spring Boot template. There are Go template. There are many templates for each of the languages, which they may not be perfect. They're not for sure, and they will never be. That's the thing. Like it's never going to be perfect because people like different styles of coding and different ways to structure their code. But it's a cool way to get started, to have something quickly. You write an AsyncAPI file and you quickly have some working code that you can actually run immediately, right? So, and you have docs as well in HTML or in Markdown. So that is really cool. And I know from some companies that they have their own internal templates. They maintain them and they don't share with the community. But yeah, and they have the code that they need, and they structure their templates, the code generation in the way they like. So that is to mention. I would say that's probably the biggest one, right? Now, it has drawbacks. So this way of working um, has many drawbacks. That was an important drawbacks that people should not be forgetting or avoiding, which is um, the very moment. So, and I'm not talking about generator or templates. I'm talking about the way of working. The getting creating an AsyncAPI file and generating code from it, or the opposite, writing your code, writing annotations on your code, and that will generate the AsyncAPI file so that you can then generate documentation and blah, 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 and integrate with other tools. Those two ways, which are usually referred to as design first and code first, they have major issues, in my opinion, both of them, which is the very moment you generate code from an AsyncAPI file, or the very moment you generate an AsyncAPI file from your code, there is a drift happening there, meaning that you might not maintain your AsyncAPI file properly, but you maintain your code, or you maintain the AsyncAPI file, but or not that you maintain, but you make changes to your AsyncAPI file, but they don't fully reflect the logic that you have written in the code, and that's a problem, right? Because what you end up with is with a system, right, with a collection of assets that are not in sync, and that's a problem. Like you will end up having documentation that is not reflecting the reality. It's saying something different than what the code is doing, and that can be really tiring and really frustrating for people. And that is happening very frequently because people just write code. They like to write code, and they may add annotations or they may not, or they may maintain the annotations or they may not, right? So, or they may not do it properly. Like, I mean, I'm thinking here like JSDoc or JavaDoc, right? Like how many times have we seen this problem with these two tools, right? Like you can annotate your code with JavaDoc or JSDoc, but yeah, how many times have you changed the meaning of something, of a function, of a method, of a class, or something, but you didn't update the docs,
Well,
right?
one nice thing
Uh,
though is to have a build that says, your Java doc doesn't match your signature. Essentially that's pretty
uh,
useful. I'm not even
oh yeah,
sure
yeah,
how
yeah.
we have that working on Zoom, but I have to look at how we do that. But it literally in the build, maybe it's just JavaDoc itself. Maybe that's just one of the
Yeah.
things. Maybe it's a switch on to JavaDoc. I don't remember, but yeah, and I because I forget to do that sometimes, or even just initially, right? Like, oh, you didn't describe this parameterized list or something like that. Oh, okay, I got to go add that um, into the
Yeah.
annotation, and so Yeah, I really dislike annotations, but annotations in Java doc is okay. It's useful, I guess. Yeah.
So we provide, so there are some libraries there that provide support for annotating your code so it can produce an AsyncAPI file out of this annotation. But again, like the problem with this that we're seeing is that most people don't have this automation in place, right? There's continuous integration systems in place that will check for the validity of this, that will make sure that the signature is the same as the one that you define there, and not to mention the human readable fields like the description or summary, which is not I'm not going to say it's impossible to parse, but yeah, we will have to be adding AI systems there, AI technology to understand what it's written there and see if it makes sense, right? So, sorry. So that's what I mean. That it's it's a complex scenario because you end up in a complex scenario because developers get frustrated that things can quickly drift, like the code and the documentation. So
But it's really just a matter of using the tools the way that they were meant to, giving attention to details, right? In other words,
yeah,
well, you don't offer the right data, you're going to get not great output from it, or you'll
yeah.
get inconsistency. So yeah, but really developers should have that discipline kind of built in, and if they're going to use these tools, use them correctly. Otherwise, just don't use them, because you're not,
Yeah,
maybe you're actually hurting things more than you're benefiting them.
indeed. And actually, this is my battle in the last years. Like, you should be doing things correctly, whatever. Either way, like if you do design first instead of annotating your code, you should also be more disciplined, right? And there should be um, automation in place to alert you that there's something that is not right and so on. But um, so it's human. It's a human factor after all, right?
Sure,
Yeah.
sure. But how I
You
sure,
mute.
but I don't understand how someone could come to your team and say, well, this tool isn't good because it doesn't read their mind. Is that, sort of, what I'm saying? Like, or
Yeah.
should there be, should the part of the parser recognize, or the compiler, the generator, whatever, the compiler should say, oh, you're missing this here, or I haven't seen this, therefore, maybe that's an answer, but that just really complicates or adds a lot of complexity to the generator. And of course, you would like to keep those things as simple as possible. So, yeah, it's a trade-off.
I completely agree. It's the thing is that nobody's complaining to me about that. Just saying, so that's something that I observed. So nobody's coming to me and saying like
Oh,
your tool sucks because it doesn't do this or that. It's like
this
so
is your
that,
own
but
critique. It's like, I wish this worked better. Okay,
yes,
that's fair.
exactly. I wish.
That's I would prefer to hear that than this hear people coming to an open source project and saying, you know, it should read my mind, but that's not it.
Yeah,
Okay.
yeah. But then the reason and the reason I'm bringing up this topic is that there has been this debate, at least in the OpenAPI field, which is it's are you a design first or a code first person, right? And um, and I think this is a false dichotomy. Right? So there are other ways of doing things here, which and this is what I call, and it's not invented by me. Spec first if you want, or spec as a config file if you want, right? I don't have a name yet, so it's just it is it's basically what GraphQL is doing or gRPC are doing. Like the code will have to match the schema definition because the code itself is going to load the schema definition into memory, and it's going to parse it, and it's going to use it as a way to understand where it needs to be listening to, what kind, in the case of GraphQL, what kind of queries or mutations you might receive. And then the only thing that you have to do is just link them to the logic, to the business logic behind them. Right? So if you do schema first in this case, right? So I think this approach is very interesting because it prevents developers from this drift that I was talking about. Like if the frameworks out there will actually support loading this API file to understand where it should be connecting to, where it should be publishing the message, where it should be subscribing to, and all these details, you will not need annotations at all, right? Because the AsyncAPI file itself is your annotation. So,
Yay. And Yay. I just have to interject. Yay.
Yeah. So you only write it. So you only write it in one place, and the only thing that you need is just a way to bind your AsyncAPI file to your specific class method that is going to do this operation. And we have that. We have, and actually, OpenAPI also has that, which is it's called Operation ID. So that you can use this field to tell the code that the function or the class method or whatever your language is that is going to perform this operation. It's called like this, or it's in this class, and this is the name of the method. That's it. And the frameworks will actually be doing that thing for you. So we created Glee, a framework at AsyncAPI, which is not yet in version 1, but we're moving quickly. And to prove that it actually works, and actually to prove that it actually works is the proof that it actually works is that you write your AsyncAPI file, and the next thing that you have to do is just write your business logic, the functions that are going to handle the message, or the function that is actually going to send the message. That's it. You don't have to do anything else. Because how to connect to a Kafka broker, how to connect to a RabbitMQ broker, how to connect to an ActiveMQ or an MQTT broker or whatever, it's always the same. It's always the same, no matter the language, no matter the framework.
Right.
You should be connecting the same way. So, and all the details that you need to configure these connections can be defined on the AsyncAPI file or along with the config file on the framework, right? So you were going to say something.
Oh, I was just going to say that I try to convince people that they shouldn't be writing those things all the time, that they should be generated, because maybe it's interesting to learn once, and then maybe the second time you're going, oh yeah, now I remember that was, you got to do that too. And then the third time you're going, why am I doing this again? Like what, like, could we have maybe, some software do that for us? Yeah. But I can't understand why people just seem to think that they're going to get some value out of that other than just the fact that it has to be done, right? That, you're you can rewrite that stuff or whatever it is that you're tinkering with. It's just not going to change anything, right? And that's the silliness of, when people start thinking of, code generation, wait a minute, no, that code generation is bad. No, actually, it's either that or libraries, or both that should take care of it for you, right? So.
Yeah, I agree. And actually, this is and it's funny that you say that. I actually got a major pushback during the history of AsyncAPI against generated code. So we actually made a generator to support continuous generation, so that you can be you generate once the code, you start writing your logic, but a month after you might change your AsyncAPI file, and you should be regenerating again on top of the existing code. So generator is capable of taking care of things like this, and not overwriting your existing code, not breaking it. And what we did is it just integrates with Git, right? In this case, so it will, if it's not a Git repo, it will not generate on top of your project. Just in case, it will you will have to actually use force to generate and overwrite your previous changes. But what we did is that you have mechanisms to generate on top of Git, so it produces changes, but they are not. You will not lose anything because you can always discard these changes using Git, and also mechanisms to avoid overwriting certain paths of your project. So don't touch that folder because this is where all my logic is, and don't touch it. Don't don't overwrite anything there, right? Or don't touch these routes, this set of routes. These are not going to change, which is not ideal because you still need to do a lot of manual work. That it's like, again, I prefer to just copy and paste the code myself and put it there, and that's it. And that's when, and I find it funny that developers usually feel this hate against generated code, and I can understand to some degree because we've seen really bad generated code in our life, but
mostly the argument that I hear though is, well, if code gets generated, how are we going to get paid? Well, you move up the food chain, right? It's like, wait a minute, is that what you really want to get paid for doing the same thing, 100 times until you retire or something like that? I don't know.
No.
It's just, that is illogical to me. So
that is a really short-sighted vision of software engineering, because it's like thinking that the project is going to end up there. Like after I finish this, I'm lost. I lose my job. You're never gonna get done building a product or a tool. It's never finished. So yeah. And as long as there is business, actually, it's going to be the opposite. If you are faster, then your company is actually going to pay you more because you're delivering more. So yeah. And if your company is not doing that, then you probably will switch companies. So
yeah, maybe some consulting companies are thinking, well, that's less billable hours or something. I don't know. It's just like, to me, it's like, oh, if we get this done really quickly and it's really, really solid, there are very few bugs, or, our customer or client just has no trouble with it, they're going to give us more work, right? That's how I view it. And it's going to be more interesting. Maybe we'll get even more, complex kinds of problems to work on. And, instead of just the stuff that they don't want to do in-house, right? So, they're really coming to you for expertise now, not just stuff that they don't want to do.
And on top of that, like, nobody's saying that you should use our templates. So you can create your own templates of code. And if you don't like our generated code, or you think that yours is better, but you still don't want to contribute back, then create your own templates. It's always going to be faster than doing the same thing over and over, especially if you're repeating the same code in multiple places, right? In multiple microservices or in multiple applications. It's going to be tiring. It's nonsense. So yeah, and like I said, like we're trying this new concept of framework, which is, like I said, it's not invented by us. The concept itself. So gRPC and GraphQL are doing the same. But that's a very limited solution, right? Because this tool is written in TypeScript. It allows you to write the functions in JavaScript or TypeScript. But if you are a Java person or another language, whatever else, you don't want to use TypeScript or JavaScript, then you cannot benefit from it. So another initiative that we have on AsyncAPI is to actually start contributing modules to or plugins, if you want, plugins to other frameworks, existing frameworks like Spring Boot, like Spring CloudStream, mainly Java, right? Because this is where mainly I would say people are, aside from also some Node.js and TypeScript, but it's Java. It's mostly Java all the way down. So, or JVM languages, and so Spring Boot is really present in Spring Boot and Spring CloudStream. So we're gonna be pushing for that, like to write plugins for these frameworks that will take care of reading this AsyncAPI file, and so that you don't have to write the same logic again and again, and you can just focus in writing the business logic, the code that is specific for your case, right? Not the one that you repeat everywhere, right? Or at least minimize it to the minimum, right? If it cannot be completely removed, like in Glee, but at least minimize it to the minimum.
Well, we took a bit of a tangent there. Not really. I mean, but a little bit. But I think it was very interesting and valuable, at least for people to hear a different opinion, if and why this code generation can help them, even if they have a different uh, viewpoint of it. Um, I was going to talk a little bit more about EDA, event-driven architecture, but I think we're nearly at an hour now, and probably reached a limit. Do you want us to just say something in general about how Async API makes EDA more wonderful, other than what
Yes.
we've already said?
So actually, first of all, before I say that, we can continue this discussion on the Thinking Out Loud episode that I already invited you to do.
Yeah,
So
yes.
we can continue this discussion there.
Yeah. So
And
for
we
listeners,
can actually put it as a continuation.
Yeah, good. Yeah. For listeners, Fran has a podcast that we'll get around to him interviewing me on Thinking Out Loud, which is a cool name for a podcast. And so that'd be good. We can continue that there then.
So yeah, and just to like short sentence, if I can, to say why AsyncAPI improves EDA, or how I would say is AsyncAPI allows you to start defining the communication between applications, being it microservices, sensors, or whatever. And with this, we can start building tools on top of it with these definitions. Like, for instance, we can start building tools like the ones we mentioned, but also I would say products on top of it, right? So products that let you discover where this who's pushing this message into the broker. Where is like, for instance, I need to consume a message where the username or the user email is present, because I need to, every time a user signs up in my product, I need to get it. I need to get this message. Is this message available somewhere? Let me search for it. So this will be an application that lets you search for it. And all these AsyncAPI files together will serve as an index, right? As a source of information that will help you with discovery and with things like triggering alerts, like you're going to change this message payload, but you're doing a breaking change here, right? So you're removing one property, for instance, or renaming it. So that's going to affect this, and these services, right? It's actually those. Do you want to contact them? So here's the contact information of this team. You might want to send an email to all of them that you're going to change this, or a notification or whatever, right? So this is the real power of AsyncAPI if you adopt it, if products adopt it, right? That you can start building things like this, powerful things like this, and you can bring order to the chaos, because EDA can be really chaotic and it can grow really quickly. So that's so I think to me that's the biggest value.
Well, I failed to mention that you're from Spain. You live in Spain, and
Yes.
I think I love Spain. And it's hard to imagine anybody who wouldn't, but there must be a few. But I always like to find out what is the food, what's the specialty of food in your area of Spain. You're sort of like South Central
Uh,
Spain, right? Not far south, but you're up a little ways from the coast. But
yeah,
what?
far away from the coast. I'm actually at the same height, if you want, as Lisbon,
Ah,
but in the border with Portugal.
yeah.
So the name of the city is Badajoz, Badajoz, depending on your accent.
Yeah.
and uh, and the specialty here, I will say, and the one that I love is gazpacho. So
Ah,
gazpacho is a tomato soup.
yeah.
It's a wrong name for gazpacho, I would say, because tomato is not really
But it's
the
cold.
main thing there.
Yeah, mostly
It's
cold.
called tomato soup, yeah.
And it's
So
excellent. Yeah, you just got to be careful. It's so delicious that you want to just have a lot of it, but it can be a bit
yes,
dangerous, if you do that. I'll leave, that maybe as an experiment to others if they don't know. But yeah, I would say we visited Malaga. Seems like a lifetime ago, but yeah, that's sort of a specialty there too, along with the
yeah,
coastal
south
fish.
of Spain.
Yeah, yeah. So yeah, wonderful. So and some
Yeah.
cerveza always goes well, or maybe a wine. Yeah. So
So actually, my region is the region of wine. I would say one
yeah.
of them actually, and ham, right, and jamón, right.
But everywhere in Spain it's
The
jamon. Yeah. So yeah, very good.
yeah, but they're mostly produced here, and then they're sold
Ah,
on anywhere, right? So this
okay.
region where I'm at is famous because we have the best jamones,
Very good.
in the world actually. So yeah, that would be another specialty, I would say, and the wines and the olive oil are also amazing here. So yeah.
Fran, I have to visit
We're a
you.
poor region.
Yeah, yeah,
Yeah,
yeah. Wonderful.
we're a poor region. We don't have many businesses. We don't have many industry. And most of the things that we have here is related to agriculture. So we're strong on agriculture. So
Excellent.
yeah.
It's got to be beautiful there. So hopefully we
Yes.
can have a meal together sometime and talk about Spain rather than or something else
Waiting for
besides
you.
software. So
Waiting for you.
okay.
Yeah.
Well, thanks again
For sure.
for um, you know allowing me to interview you, and I'll look forward to thinking out loud and where we'll see you. Thank you.
Thanks a lot for inviting me. It was a pleasure. Bye bye.